Hey y'all, so this is going to be a relatively similar video to the G120R frame, but it seems like that was a pretty useful format, so I'm going to be doing something similar. I'm going to be just scrolling through the process and explaining some of the development on this new lower I'm working on. So this is a bufferless AR9 lower for the BC9, the Bear Creek one. But the main gimmick of this is that it has these two really large, like laser cut metal side plates, and those kind of bear all the stress. I'll explain that a little bit more later. And also talking about how I did the documentation, which is a big thing that not a lot of people do, and sometimes isn't always done as thoroughly as it could have been. So I'm going to just start by kind of rolling everything back and showing you. So I always like to import my references. Now my references for this one are I have an old Huffman Tactical lower just because their dimensions are very tried and true. I have my BC9 reference, and I have my ARN reference that I did previously. Now this one I'm not abandoning it because I think in a lot of formats and plastics it'll work great, but I've had some pretty serious reliability issues with PLA Plus. Bufferless is just really notoriously violent, so I think for specifically for a bufferless setup, it's better to move to this reinforced style. So this one probably going to be depreciated, I guess. I'm not going to take it down or anything, but it's definitely outdated. And if you are considering making one of these, then I would definitely check out the new one once it drops. So I brought in all my references with the derivation. Then first thing we have, let me hide these now, is I'm starting my main sketches. So this first sketch I have is the actual shape of the sheet metal. So I started with that because that's kind of one of the main, that's kind of what everything's designed around. Now, this part changes shape throughout the process, and I don't go back and modify the sketch. My workflow is often I do everything in a later feature rather than modifying my original sketch, which you could do it that way, you could not. Who cares? It's really up to you. So essentially the main surface on this is I actually am not sure what you even call this. The rear buffer tower surface. Um, but that's essentially where I want all of the stress going. So I have the plate mating up with the upper right here, and there's enough clearance for the bolt carrier to pass through, and it's kind of a toss up between the width of this. I'll explain why there are some considerations for the distance these plates are from the center line. So yeah, that's my first step is establishing kind of the focal point. And if this were a purely polymer lower, this would just be like a block out of the general shape. Here I'm just bringing in some more reference stuff. I probably could have scrolled back and done this at the beginning, but I'm not a very organized person, and the final works out just fine. So then here's the actual polymer part. Um, Now I've extruded this out to those faces. The polymer section is 26 millimeters. That's just because it's in the middle. So then this is just fixing an error there. I bring this out to get the little beaver tail to actually fit nicely. I don't want there to be a sharp corner. So when the beaver tail ends here, I wouldn't want the plate to go there because then you would have a perfectly square corner and it would be really uncomfortable to hold. So then what I'm doing is, well, firstly, I am giving this a fillet. Now it's variable radius because I want it to flow back into the sharp part. And then I boolean it back in, clean it up with some fillets, and kind of blend it back into the lower. All right, now what I'm doing is taking out the slot for the trigger guard, and this was already established in that first sketch. Then I'm clearing out corners. This is all kind of, par for the course. I've explained this stuff before, but you get the idea. Then I'm bringing out the magwell. Again, I want to leave clearance for the plates here. So you can see I've already taken out this slot for the mag release. Now, because I want the plates to be symmetrical, I'm not mirroring this plate until the very end because they're the same part. But you can see here this like thin bottom part. I end up changing this a couple times later down the line for the sake of like home manufacturability. because this would be really, really tough to cut. You would have to use like a scroll saw or something, and I don't even know if they make metal blades for this. That would be a nightmare. So later I end up taking that part out, and I could edit it here, but that would probably break some features down the line. So I just do it separately later on, which I feel like is fine, and I haven't really run into any major issues with that. I know people professionally and formally trained would probably tell you that's a terrible idea, especially if you're working with a team. But I'm not, so I can do whatever the hell I want. All right, then I'm taking out the magwell, and again, these dimensions are, or of the magazine recess are based on Hoffman's, not sorry, not Hoffman's. Yeah, actually, it's based on the, if I can remember the name. Yeah, it's based on my old ARN, and that one is based on the SL9 dimensions. So it is based on Hoffman, but not that Hoffman. Okay, I will. Now here's the thing with Onshape that is rather annoying is the names, if you change them later, will kind of affect that part even further down the feature tree. Like it doesn't save names in specific points in the rollback. So this is called trigger guard now because it later became that, which I think is a little stupid, but right, moving down a little more. I'm bringing these shapes out. This was just an extrusion. Then I filleted those corners. I brought out this little tab. This is for the little pin holder for the actual mag release. And again, that'll be replicated on the other side because I want those parts to be the same. Then I'm bringing that part out, doing it on the other side. Moving back here, doing the actual fire control group recess. Now these are based on Hoffman's because again, they're tried and true. That's something that, I mean, there's no reason to measure your own parts when there's already an established standard. I would rather it be, the same as an existing project and standardized and everybody knows what to expect than it to be like a perfect replica of a real lower that I have. I would always recommend that you stick with a standard if it exists, and Hoffman seems like a great standard to stick to. Then I'm adding some tolerances with this move face function. I want that to stick away a little bit from the plate just so like expansion in the print doesn't cause them to be too tight of a fit. Making the fire control group holes. Now these are oversized, and that is because I explained this in the documentation, but the pins that go through here are not the standard AR fire control group pins. They're M4 screws. And so the holes need to be a little bit larger, but the reason they're even further oversized in this part is because any of like the pin shear stresses I don't want to transfer to the plastic part. I want those to go entirely through this. So ideally they don't even touch this, but they do touch it just to keep things stable, but not enough to actually crack anything. So that's like if you see later on these takedown pinholes are actually quite a bit larger, and that's because those pins are larger. But that's explaining that now. That's just because I don't want the plastic part to be overstressed. Confirm recording. We're good. All right, I'm adding those fire control, no, takedown pinholes, and you can see they're oversized by like a millimeter. Then doing the grip hole, which is designed for an M5 insert. I've had some like they're kind of different sizes, but they're sort of not. And like I found that if you're designing around them, it's better to not specify a standard for hardware because there's just so many different versions, and you wouldn't want to like I'm not going to tell somebody to buy a specific kind of insert if they already have a bunch of M5s. So I found it's better to just give a general hole, and then either you can just force it through with a soldering iron, or you can drill it out a little bit. I don't know. That feels better to me. Now next up, I gotta stop doing that thing with my mouth. I always cut it out, but I am not gonna do it 40 times if I keep saying another video. Here I'm working on the rear stock block. Now this is kind of another thing. I end up separating this into a separate piece for the sake of printing this vertically, but I haven't done that here. So that's something that might be smart to scroll back, but is anybody really gonna do that? I did it again. Sorry. Um, Here I'm bringing out the little slot for the buffer plate. Now, it was never designed to actually make impact on this plastic part, but there's a little plastic plate that comes in here. Now, originally these two, I don't know if you can see these two holes in the side plate were designed for M5 screws that go all the way through, and then the bolt would crash into that with a buffer pad. But I decided to keep that strictly as like a contingency if people are unable to cut the slot, which we'll see later. Um, but that is really not an optimal solution. But I like to keep it, you know, it doesn't compromise strength or looks at all. And if people do screw up the plate on this last part, then I don't want them to have to, redo the whole thing. I want to give them a little alternative that they can use. So what am I doing here? Here I'm bringing these parts away from the actual. I still don't know what you would call this, but my point is that it's not touching the upper, so that any of those forces from the upper don't get transferred to the plastic. Then yeah, here's the actual plate. It's kind of just a T shape that locks into these sides. Again, they're clearanced. I'm not super experienced with sheet metal cutting, but I know that you can't have the same sized hole. That would be like an interference fit with sheet metal, which is not a good idea. Then I add a hole for like if you want to. I'm kind of, again, this is kind of a future proofing thing. Like if I ever want to add like, well, I don't know, like a TPU buffer pad or something that needs to be screwed into this plate, I want to give myself a hole to do that in the future. Um, so just set yourself up for future changes, especially with like sheet metal parts that you can't easily reprint. I'd have to put another Senka send order, and I don't want to do that. Yeah, here I am separating these. I like to use this kind of peg and slot system for a lot of printed parts. I find it works a little better than the dovetail, and you don't get those weird sharp corners. Like printed parts always kind of bow out with a sharp corner. I don't know if you can see that path I'm tracing, and that never really fits nice. You have to kind of radius those edges more, and it never really works great. So this is fine for like this is not a strength critical fit again because the side plate holds everything together, but just kind of keeps it in place. All right, I'm gonna hide this for now because there are some features here that come up later. All right, next up, I'm making this little plate, not plate, this little recess for a serial number. Now, I always like to add a spot for this. I did this on the Neo 9. It's not sufficient for like NFA things. I think you need a specific size plate to embed it in, but I always serialize mine just for the sake of organization. Um, so I always make a spot for that, and if you don't use it, it looks cool anyway. Here's the name of the platform. Here are just some more kind of subtle changes. I'm bringing the end of the trigger guard out. I don't remember what this is for, but I bet I will shortly. Okay, now I'm doing the mag catch. I don't know what you would even call this. Hinge blocks. So the actual pin that it rotates on goes there. So I add those holes, then oh, I guess I had done that earlier. So this is now a separate part, the mag catch. Again, these dimensions are from the SL9. This actually works really, really well in practice. So why redesign something if there's already a standard, you know? Did it again. All right, here I'm adding some just basic cosmetic features to the mag catch. Want it to look nice. All right, here now I'm adding the recess for the ejector. Now I want this to be a separate part for one that so you can use the existing Hoffman ejector, but also like they have aluminum versions, so I wanted to keep the part exactly the same. So what I'm doing here is I am just getting this negative volume by subtracting this lower from that part. So I have that now. I clean it up with some delete face functions. I move it in half a millimeter just to get it to fit nicely and be kind of, I want it like it's going to be touching the side plate, which I think will make it a little bit sturdier. I guess the plate, I haven't mirrored it yet, but you get the idea. Then I cut it out, clean up those edges with some fillets. Just don't want to have any ridiculously thin parts, so I like to round those corners. That one printed up fine. Labeling. I've decided to label stuff on this one just because a lot of it's going to be covered up. And dude, people never read the directions. I had to add a warning later down the line, just telling you not to, use it without the side plates because it will blow up. I shouldn't have to do that. People should just read the directions. But dude, I'm gonna be honest, I get it. I never read the directions unless I have an issue. Then I'm adding some features. These are kind of inspired by the DB Alloy MP. I just love that type of thing. I don't know, unnecessary, but looks nice. Adding some more information, taking out material on the takedown lug. Then I'm cleaning stuff up, added chamfers. Then I started working on the fire selector drum. So this one had to be custom because the actual thing is wider, and I mean, I could have cut out like an arc in the side plate for the fire selector, but that would have been ridiculously, like, I would never want to compromise strength that much. I think that would just be stupid. I think a better solution is to just do a printed fire selector, and it's not like, it's just not FRT friendly. But I don't think any printed lower really is, except for like the SL9. Here I'm just adding those features for this, adding the handle, or I don't know what you call this, selector. Now what I'm doing here is I've chamfered this. So this is going to be the actual track for the detent. Now this one works surprisingly well. I didn't even have to adjust any tolerances. It kind of just worked first try. Then I am giving it a centerline access to rotate, boolean, then a little bit of a crackhead solution. I'm actually making the rest of the track, so I chamfer that. I don't know if you can see that. Then I adjust some tolerances and boolean. So now I have the slot that, like, when it's in between positions, the detent will hold it from going side to side, so it can't just fall out. This is pretty much just how the regular fire selector works. Then I'm cleaning up those edges, smoothing them out. All right, what's next? Oh, cutting out these triangle indicators on these. Yeah, filleting them, chamfering them. This turned out nicely. I just like how that looks. Um, what's next? Oh, this is just a placeholder for the buffer pad. You can use like a furniture pad or something. I talk about that later in the documentation. Let's see what's next. Not sure what I was deleting. Oh yeah, here I'm working on a kind of chopping out that bottom strut part. I'm not exactly sure what you would call that, but somebody on Reddit told me that, and it pointed out that this would be really hard to cut with home tools, and I very much agree. So I'm going to be cutting that part out, and then I'm bringing that back into the lower, kind of bringing everything back up. Let's see it on this side. Then I'm, just cleaning up faces like that. So now there are no kind of internal cuts on this one except for the slot, but I have a contingency for that. Sorry, this video is incredibly disjointed. I don't have a script or anything. I'm kind of just walking through it. But you know what? It's better than nothing. Fuck if I can remember what this is for. That block, I guess. I mean, this would be the kind of thing that you would be better off doing. Like, SolidWorks has their like instant 3D stuff. I mean, that's kind of how I treat Onshape. But like, other than feature complexity, there's really no downside other than organization. So you can kind of just refine a part rather than having a set of discrete features. Then I'm smoothing out those corners, adding, I don't know what I'm adding. Oh yeah, I'm making the little recess so you can actually pull the pin out to take the mag release out. I have that warning now. That's just a sketch with an extrude. Um, and again, heed that warning or it will just break. Cleaning up some topology because I didn't like those fillets. Then I hit him with a better fillet. Sorry, topology is not the right word. I think tangency is. Then I'm kind of smoothing out all the corners, hitting the Picatinny rail. I'm moving these, sorry, expanding these by a little bit because I forgot to oversize those. Then I'm moving the actual slots for the screw buffer back just to give them more room for padding because I think they'll need more. Um, Here I'm making just a placeholder for the recoil spring. This is not dimensionally accurate at all. Then here's something that is kind of, I don't do this often, but I have these separated into their own folder. So this is for like a minimal back. I say back plate, it's really not. And this is the kind of thing that I wanted to keep in case I ever decided to come back to it, but I don't think I'm going to run with it. It just makes this part higher than I would like, and I like having a stock attached lower, so that you don't need like optic risers or anything. So I just keep that suppressed when I don't need it. Then I'm adding the QD stock sling port. Sorry, I don't know if you can tell. I am not operating on a whole lot of sleep right now. Then what I'm doing here is I'm separating out the trigger guard. Now I did this for print quality's sake. I want to print it on the floor like this for best quality. And I've kind of explained this philosophy before, but I have an Ender 3 V2. It's not a nice printer by any means, and it doesn't have very good overhang performance. I think I've tuned it to about as good as it could have been, but I just hate how supported surfaces look. I think they look really bad, and I think a responsible 3D printer designer avoids surfaces like that when they can. So this is a separate part, and I always like to do that, especially on trigger guards, because they kind of inherently have that upside down surface. So this is a separate thing, and then I build out those kind of faux dovetails. These worked really great. Like the tolerances are kind of perfect on these. Um, so yeah, this is a separate part. It gets printed on its side. So that way, the only thing you're printing is this flat on its top. All right, we're getting kind of down to the end here. I'm adding this little end stop because I realized that without a magazine, this could kind of fall into the receiver more than it should. Um, Upon further testing, that might be unnecessary, but it's good to have that because I'm not sure exactly what's keeping it down. I think it might be a specific length of spring I have isn't strong enough to overcome friction. So I'm going to be keeping this. And that just clamps onto or sorry, it limits itself by hitting the metal plate. Cleaning up those parts. Da da da. We've seen that a million times. Alright, what's next? I'm giving these some more clearance. I didn't want the bolt to if it's at all misaligned, I didn't want it to scoop out parts of this that would cause a lot of friction and stuff. Then I'm hitting it with a chamfer. Alright, so now I'm going to kind of just show you this in assembly. Alright, so we're here in the assembly now. Assembly is where you just it's kind of interference testing, or integration testing. Integrated testing. Sorry, Jesus, I don't know any of these terms. Where you can just kind of test all the parts side by side. So I have my magazine in here, pistol grip attached, and I always like to just go section view so you can see, where things fit. Pistol grip fits good. All the holes are aligned. You have that nice separation that the real AR has. I mean, other than that, it's pretty box standard. It's just a lower, so there's not a whole lot of testing that has to be done between it and the upper. I have a hand stop that I designed for this. That's about as much as I have in assembly. So I'll bring you to showing you the real part, and then I'll talk about documentation. Okay, so this is my flash is on for some reason. This is the actual part that I produced. It's it's about what you would expect. I have, my takedown pins, and you can see that the fit is very loose because those holes are oversized, like I talked about. Pistol grip fits great. This is my first printed draft of this part, which is I was lucky that everything fit really nicely. So I have all my inserts in here. I have the mag catch with a spring that fits really nicely. I'm very proud of how that turned out. I have the end plate here with that locking system. This did not turn out as I would like, but I think I'm going to keep it just because this really only needs to support up and down, which it does just fine. Um, on the other side, we have the fire selector here. Now, it's a little finicky without the side plates, but that detent works quite well. I don't know if you can hear how crisp that is. Um, but that, I mean, I don't think I could have asked for that to go any better. Fitment with the upper is quite nice. I have, the bolt goes in really nicely. I have about like 5 millimeters of clearance from the end plate. That's like that front edge is where the end plate will be. So then I have room for my buffer padding. I would say very successful first draft, and I'm waiting on side plates. We'll see how that turns out. All right, I'll now go over the documentation part. So I always like to work on these as I'm doing the projects because, any kind of it kind of helps me think about error correction as I'm doing it. Maybe because it's like, well, if I write this down, then it's kind of codified. So if it's kind of a sketchy solution, I might be more tempted to make something more robust. So I always like to do a bill of materials. These are not always perfect, as people have pointed out. That's my bad. I don't know. It's hard to organize these, but like, you're smart. You can figure things out. Um, so typically what I do is I'll put in all the hardware in Onshape. That's not really necessary if you can just remember what it is you're doing. But I like to do that just so I can get length and actually see how things fit. Like if I had thought of a length for this and it turned out like, oh wow, that's actually way too long, then I can see that and I can change it. So I like to just go through and put all my hardware down. Again, I don't specify specific lengths or like, I guess, grip patterns of the threaded inserts because there's just such a variety of them and I don't want to like lock people off from doing what they have. You can make it work. Like that's what this hobby is all about, is making things yourself. Um, I talk about stuff like this. I always like to color code it by size and then also like springs and like nails and stuff. I always like to make green. And then kind of standard parts are blue. Although I screwed that up, that should be green. Um, and then on stuff that needs a little bit more explanation, I like to add an addendum. So I always like to do an overview, kind of explaining what it is. Now this will be in the Odyssey description too, but some people sometimes, I don't know. It's nice to clarify the goals of the project so that people don't expect what they can't get out of it. Um, so I like to be transparent about like this this won't work with like a super safety or something like that because the fire control group is just so different and wider. Um, I talk about drop-in triggers and stuff, but drop-in FRTs should still work because those just go in the little uppercut. I talk about bolt padding here. Um, I'll probably work on a little bit more because I don't love this solution. I don't like telling people to just like, oh, get this general kind of part. I would like to maybe find a more specific type that works, but again, that'll require testing once my actual sheet metal parts get here. Another thing I like to do is a visual hardware diagram, just like in place of assembly instructions. I think this can give people a really good sense of where things go. Um, so I like to just do call outs about like the different sizes and stuff, explaining things and providing alternative views. Um, I talk some more about the plates and more about the kind of backup holes. That's something that I think is going to be pretty important on this project if you're trying to do it at home. But I also, like, it's 25 bucks, I think I send. I feel like you could do it cheaper there rather than buying a whole bunch of stock material. It's 0.125 inches. I don't know what that is in gauge, but it's a pretty common sheet metal. It's very cheap at Simco. Um, I always like to specify orientation. Sometimes this changes. Like with the ARN, the specified orientation had to change just because it was not good. Um, that's something that you can only figure out once you've tested. I add notes and things, and then here's another thing I'll pull up now is I have a cutting guide. Now this is my first part with like big sheet metal elements, so I've provided a home cutting guide. You can measure this, make sure your printer's calibrated correctly. I've got center points for all the drills. I think this will be pretty helpful. If any of you have like issues with this, if you decide to cut it at home, let me know. I can help you out, of course. Other than that, I like to credit people. Hoffman Tactical, I took a lot of his dimensions. Forever grateful for everything that dude does for this community. It's insane. He's what I aspire to be. And then thank you to all my patrons, which I have a couple now. I really appreciate that. Like, I'm not a professional by any means, and I'm so glad people are getting enough out of my projects that they, like, God forbid, feel the need to like financially support me. I'm so grateful for that. And everybody who just says nice shit on the internet. It really means a lot. Like, I feel like some people kind of act like it doesn't get to them, but it does. And I mean it. I really like it. Thank you. You're very nice and you're very supportive, and it means a lot. That's pretty much all I have on documentation. Mine are kind of bare bones. I don't typically have assembly guides except for stuff like the deck bar where it actually is really complicated. But I mean, this is a community of engineers and creatives. I feel like you can figure it out. I would say that's all I have for documentation. We'll see if this part gets put in after the real life segment. But if not, I appreciate you. Thank you very much for watching, and I hope you got something out of this one.